Relative to the origin O, the position vectors of the points A and B are OA is equal to 9, 0. OB is equal to 3, 6. Also, the points D and E are on AB and OA respectively and are such that AD is equal to 1/3 of AB. OE is equal to 1/3 of OA. Those we need to pay special attention to in solving this problem. Our duty is to express in the form, and we have the form right here, as this form is a column vector. So express in the form of a column vector the vector OD. Our duty is to find the vector that will go from O to D. Find the vector OD, which is the one that will go from O to D. In finding the vector OD, we may make use of any path that goes from O to D. The best route is from O to A, then from A to D. And we will start by presenting the vector OA. We will go from O to D, but in doing that, we will go from O to A first, then from A to D. There we have the vector OA as given, because we are going to go from O to A. We need to have the vector OA, and the vector OA is given in the statement of the problem. It is given that AD is 1/3 of AB. From A to D is 1/3 the distance from A to B. AD is equal to 1/3 of AB. But we have found AB already. AB was found to be -6, 6. Therefore, AD, which is 1/3 of AB, will be 1/3 of -6, 6. That's what AD will be. We therefore have the motion from A to D. We also have the motion from O to A. Therefore, in going from A to D, we may say, go from O to A, then from A to D. There's no difficulty because we have the equivalent of each section of the motion. In finding OD, we should not have too much difficulty then. We go from O to A, as is seen right there. That is the first part of the motion, which is the vector 9, 0. The vector 9, 0 is placed there first. We include that vector 9, 0. The first part of the motion is in the same direction as OA. O to A. And the first part of the motion is in that same direction. We therefore include the vector OA, which is this one, just as it is. The second part of the motion is from A to D. The second part is from A to D. The second part is in the same direction as AB and is therefore added just as it is. Notice that from A to D, which is the second part of the motion, is in the same direction as the vector AB. So when we take 1/3 of AB, then that should be added just as it is because it is in the same direction of the vector AB. Now we have OD is equal to 9, 0 plus 1/3 -6, 6. What do? All that we need to do, we are going to take the 9, 0 and add 1/3 of -6, 6 to it. 1/3 of -6 is -2 as we have it here, and 1/3 of 6 is 2. Therefore, what we should really have is OD is equal to 90. 1/3 of negative 6 will be negative 2. And no doubt we will just add 9 with negative 2. 9 plus negative 2 is equal to 7. Then we say 0 plus 2 is equal to 2. So that's the end of it. Well, I hope so. The final vector will turn out, therefore, to be OD is equal to 7, 2. Any movement that is comprised of a set of other movements is the sum of those other movements. The movement from O to D is comprised of the movement from O to A and the one from A to D. Therefore, the entire motion from O to D will be the sum of the movement from O to A and the movement from A to D. We will find the sum of those movements. And that is how we will find what we call in mathematics the resultant of vectors. The resultant of vectors is their sum. And we've found OD by taking the resultant of the vector OA and the vector AD. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.